Good morning, grade 12. Sorry, and welcome to our first video lesson of this week. Today we are going to look at identities involving compound and double angles. Now, identities is where you have to prove that the left-hand side equals a right-hand side. So let's start with this sum with its left-hand side. This cos 2 theta we can split into using the formula for double angles. And we can do that by using the 1 minus 2 sine squared theta. Over the sine 2 theta, we can also use this double angle formula. Sine 2 theta is 2 sine theta cos theta. Now we need to multiply this minus in. Then it's 1 minus 1 plus 2 sine squared theta over 2 sine theta cos theta. 1 minus 1 falls away. Then we're left with 2 sine squared theta. So we can expand this into 2 sine theta over 2 sine theta cos theta. And now everything, or most of it, can cancel out. The 2 with the 2, the sine with the sine, and we're left with sine theta over cos theta. And that is nothing else but tan theta. And there we have our right-hand side. And that's how we proved that this identity equals that identity. Let's look at another example. Prove that this left-hand side equals that right-hand side. Again, let's start with the left-hand side. This sine 2a can be broken up into 2 sine a cos a. So we have 1 plus 2 sine a cos a over cos 2 alpha or cos 2a can be written as cos squared a minus sine squared a. Now I'm going to take this 1 because I know there's another identity, sine squared plus cos squared, that will equal 1. And I'm going to use that because I can then sort of transform this into a trinomial. So this 1 becomes cos squared a plus sine squared a, and the rest stays the same. Here in the denominator, I have the difference of squares. So I can split that up into two brackets. Cos A minus sine A and cos A plus sine A. Now we have to factorize this trinomial. We have two brackets. It's cos squared and sine squared. So it's cos A, sine A, sine A, and I have to get plus 2. So it's plus that, over cos A minus sine A times cos A plus sine A. And again, I can cancel out. Cos A plus sine A, and I'm left with cos A plus sine A over cos A minus sine. Cos A plus sine A over cos A minus sine A. And that's what I had to prove. So my left-hand side now is equal to the right-hand side. And that concludes that sum. Another example. This is now a follow-up on question 2's identity that we had to prove. Now they ask us for a follow-up, now calculate that. And if you look closely, you will see it corresponds to the right-hand side of the previous identity. So let's rewrite this in terms of that. Cos 15 plus sine 15 over cos 15 minus sine 15 will then be equal to, and now I'm going to rewrite that, and in the place of A, I'm going to write 15. So it will be 1 plus sine 2 times 15 over cos 2 times 15. That becomes 1 plus sine 30 degrees over cos 30 degrees. These are special triangles. So you have to draw your special triangle with the 60 and the 30 degrees, and it's 1, 2, square root 3. The 1 stays there, plus sine 30 is a half. Divide by cos 30 is square 3 over 2. One plus a half gives me 3 halves. Divide by square root 3 over 2. This is 3 halves. The divide becomes a times, and you get the inverse or the reciprocal. Now the 2's can cancel out, and we get 3 over square root 3. But it's not allowed to end your sum with a square root in a denominator, so I have to multiply it with a special 1, and that is square 3 over square 3. Then you will get 3 square 3 over 3. Again, these can cancel out, and my answer is square root 3. Example 3. For which values of theta will this identity be undefined? Now, undefined means you either divide by a 0, so if this equals to 0, or you land on one of the asymptotes. And only tan has asymptotes. And where are tan's asymptotes? At 90 degrees and 180 degrees further to 70 degrees. So we start by saying tan theta is undefined for theta equaling 90 degrees plus k times 180 degrees. Because every 90 degree and 180 degrees further, it's 270, and then 180 degrees further and 180 degrees further, they all will have the asymptotes for tan. But this is not the only thing where this identity will be undefined. It will also be undefined where sine 2 theta equals 0. So we have to write and for sine 2 theta equaling 0. So 2 theta must be the sine's inverse of 0, and that is at 0 degrees. But if you look at the sine graph, this is 0 and that is 360. Where is sine 0? It's 0 at 0 and 180 degrees further at 180 and 180 degrees further at 360. So you say 2 theta will be equal to 180 plus k times 360, or 2 theta will be 0 plus k times 360. This 360 is because the sine graph completes in 360 degrees. But I'm still using 2 theta, so now you need to divide all the degrees by 2. And then you have theta will be 90 degrees plus k times 180 degrees for sine 2 theta. This is sine theta. Or theta divide by 2 everywhere will be equal to 0 degrees plus k times 180 degrees. And k is an element of z. Now, for a marker, please indicate where all your answers are. So, we concluded that it will be for 90 degrees, again for 90 degrees, and for 0 degrees. And k is an element of z. Let's do another one. For which values of A is this identity undefined? Again, we have a tan somewhere, so we need to say the tan's asymptotes, as well as this one must not be 0, and that one must not be 0. Okay, so let's start with the tan. Tan A is undefined. Oops. For A equaling, and we can remember that tan has asymptotes at 90 degrees and every 180 degrees further. So that covers tan on its own. Now we must also say for these and these denominators. Or where 1 plus tan A equals 0. And tan A will therefore be minus 1 over 1. Now, where is tan negative? If you draw your cast diagram, tan is positive there, so it will be negative here and here in those two quadrants. For tan to be negative 1, you work out the reference angle, and that is tan minus 1 of positive 1, which will give you 45 degrees. So that is my reference angle. I use this reference angle in those two quadrants to determine what the degrees will be. So A equals 180 minus 45 plus K times 180 degrees, because I'm working with tan, and tan completes its graph in 180 degrees. So you always put the period here of the main mother graph. A will therefore be 135 degrees plus K times 180. Okay, that covered this quadrant, but we still need to say this one as well. Or A will be 360 minus 45 plus K times 180. 360 minus 45 is there. So A will be 315 degrees plus K times 180 degrees. And K is still element of Z. Right. We covered tan. We covered this denominator. Now we must say if this one also is 0, it will be undefined. So we have a next or. If 1 plus sine 2a equals 0. So sine 2a will be minus 1. Again, we look at sine where, only a positive one. What will that reference angle be? And it's 90 degrees. Where is sine negative? Sine is negative here and here. So 2a, the reference angle is 90 degrees. 2a will be equal to 180 plus 90 degrees to get into this quadrant, plus K times 360 degrees. This is the period for sine. But I want A alone, so I have to divide all the degrees by 2. But let's first work out what is this. 270 plus k times 360. A will be half of 270 is 135 plus k times half of 360 is 180 degrees. Or 2a equals 360 minus 90 plus k times 360 degrees. 2a will then be 270 plus k times 360 degrees. Divide by 2. A equals 135 plus k times 180 degrees. And k is still an element of z. Okay, let's show the marker what all the answers are. We first get a 90 degrees plus k times 180. Then we get 135 plus k times 180. And then we get 100. Oops, here's a focus. No, it's not that. And then we get this one. These are 315. These two are the same as that one. So they are my final answers for if that identity is undefined. Your homework for the next lesson is exercise 6 and exercise 9, all these sums.